Alright, so today is lesson 3, finding the distance between 2 points. Some of them it'll be really simple and some it'll just be a little bit more because we're going to have a special formula to use. So if we take a look first, you have some warm-ups we're doing from yesterday using the segment addition postulate. Whole thing is equal to sum of the parts. So draw each picture, complete them, and then come back and check your work. Alright, so with number 1, M is between L and N, so you can set up that picture, label your parts, use the segment addition postulate that the whole thing is equal to sum of the parts. Go through solving for X, and then also having to find MN, because that was in the instructions, plugging back in. With number 2, because we know that AB is equal to BC, I created that line segment with B in the middle. Mark that they are equal, and the fact that they are equal and congruent meant that I could just take each of their measures, set them equal to each other to solve for X, and that was all I had to do. If you didn't know how to do these, you just copied it down, or you had something wrong, then you needed to be seeing me to get help. So if that's the case, pause it and get help. So now we're going to start with distance, and we're just looking at simple horizontal and vertical lines. So on this picture, what is the length of AB? 1, 2, 3, 4, 5, 6, 7. AB is 7. CD, 1, 2, 3. What about EF? How do we figure out what that is? When it's straight, horizontal, and vertical, we can just count. When it's not, we have to utilize other things. So if we look at the bottom here, that's all good. Well, how are we going to do EF? Something from the past would be to create a nice right triangle here. So now I know that the vertical distance is 4. The horizontal distance is 3, and it's a right triangle. I'm looking for that hypotenuse. Remember Pythagorean theorem. The hypotenuse is the c squared is the longest one. So I have 4 squared plus 3 squared equaling the piece I'm looking for. To get the x by itself, I have to do the square root to undo it. Those are opposite of each other. So x is equal to the square root of 4 squared plus 3 squared. So there's my square root, second x squared, 4 squared plus 3 squared. So that meant x is equal to 5, and that's the answer here. Taking a look at the next page, you can do Pythagorean theorem like we just did on that last question, or you could use this distance formula. It's the exact same thing. So what you would have to do now, just to kind of understand how they're the same thing, is watch the second video that's attached in Google Classroom, and it's the how to derive the distance formula from the Pythagorean theorem. Okay. So to prove that you've actually watched that video, you need to put 2 stars in the box that says distance formula, one above the word distance formula and one below. Moving to part B for these examples, we can use our number line to find the measure of each of these segments. So because it's a number line, it's horizontal, you can just count, or you can set it up to do that math problem. But since it's horizontal, we will just count it. So BD, starting at B, which is -7, going to D, which is -1, it's a distance of 6. Okay, so I started at B, and it's going to D, and I counted 1, 2, 3, 4, 5, and 6. Repeating that process, go ahead and try B, C, and D. So now for that distance formula, you have to use the distance formula to find the distance between each pair of points and leave it in radical form. So the first thing, that distance formula, you recall, this is our distance formula. So, possibly you're wondering why I use the colors. And that's because we have two different points. I'm going to label the first one my x1, y1, because remember your points are in the order x, y. And then my second one, x2, y2. So now you can see really clearly how they need to be plugged into your formula. Where those numbers are is where you plug them in. I'm going to start that over again, so there's space. So what is my x2? x2 is 15. And then I needed x1, which is 0. And y2 is 20. And y1 is 0. So again, I did it this way because if you ever get negatives, you need to make it work out right. So it would be the parentheses, x2, and then put the minus sign, go find x1. Write it in. Simplifying it down, it's asking you to leave it in radical form if it doesn't work out nicely. So if we put in just what's on the inside, we can figure out our solution and whether or not we need it to stay in radical form. It'll be much easier this way. So I got 245. So keep the square root. It's the square root of 245. If you recognize it right off, you know whether or not you're done. And if not, second x squared to get our square root, and then second negative to follow up our answer. Okay, it didn't work out nice, so this is it, I'm done. Alright. I'm going to show it to you just without the colors this time. Labeling your point, x1, y1, and x2, y2. So my formula says d equals the square root of. In my first group, I need to get an x2. I labeled that on -8. Then I need a minus sign. Then an x1, which is a -12. So I use an extra set of parentheses to keep track. So close our parentheses squared, and then the plus. Now the y2 group. y2 is 3. Then I need a minus sign, and a y1, 0. Close it and square it. So again, we're going into our calculator, typing just what's on the inside of the square root. So parentheses, -8, minus, parentheses, -12, close it, square it, plus, parentheses, 3 minus 0 squared. So I got 25. Is the square root of 25 something that works out nice? Again, if you don't know that, second square root, second answer, and it'll tell you. So there's no reason to leave it in a square root because it is a perfect square. One more time. x1, y1, x2, y2. This is the formula. x2 minus x1 squared plus y2 minus y1 squared. So start with my pieces. I need the next 2. That was 6. I need a minus sign, then the next one, which is 11. I need a y2, which is 2, and then my minus sign, and then y1 is a negative 12. Logging it in. Nope, I don't want it in the square root yet, do I? So 6 minus 11 squared plus 2 minus a negative 12. You get 221. So you gotta decide, is this a perfect square, is it not? If you don't know, you would put it into your calculator to determine it. You'll find yes, it is not. So we're going to leave it here. So again, if you're actually watching the video, then you should be following along and you should have some little tidbits. So on this next page, at the very top of the page, write the word hi and a smiley face. Get you some bonus points if you're watching the video. This last 3, we are using our Pythagorean theorem instead because again, it's the same as the distance formula. So we find where these 2 points come together to create our right triangle. We count our vertical distance and see it's 7 units tall, and then horizontal, it's 6 units wide. This is what I'm looking for. So again, Pythagorean theorem says a squared plus b squared equals c squared. The c squared, the one after the equal sign is by itself, is always that hypotenuse. It's across from the right angle. So it doesn't matter which one is 7 and which one is 6, we just plug it in. We're trying to find that distance for the hypotenuse. To get it by itself, you take the square root. So the distance will be the square root of 7 squared plus 6 squared. And it says leave it in radical form. This didn't work out nicely, so it's going to actually help me to have this all by itself. Okay, so then leaving it the square root, d is going to be the square root of 85. Like in theory, if you were going to be graphing or something, that wouldn't really help you, but we're not, so it doesn't matter keeping it as a square root. So trying these. Finding vertical and horizontal distances. Right, so 5 squared plus 6 squared is equal to d squared. To get d, I just take the square root. So we gotta find out if this is a perfect square or not. I got the square root of 61, and I can tell you that that is not a perfect square. And you know how to test it at this point in time. Last one. 3 tall, 4 wide, looking for that hypotenuse. I'm taking the square root. So one thing with triangles, it's a special thing. With the right triangles, if you've got a leg that's 3 and a leg that's 4, you know the hypotenuse is 5. It's a special relationship, 3, 4, 5. And if it's any multiples of those all the way around, it'll work that way too. So now it's time for you to do the homework. For the homework, you are doing the left side of number 1. And you will do 2A and 2B. If you have any questions, please see me. And if you've watched your video, make sure you put another star on this page.